Hello, it's Amiga upgrading time, and in this video I'm going to install a new accelerator card in my Amiga 2000. And I've always wanted to add an accelerator to it, but I didn't want to go down the Pistorm route. So, after a lot of saving, I purchased this new card, and it's sadly been sitting behind me for quite a few months now waiting to be installed. Now, I'm not the first person to talk about this particular accelerator, and you may well have seen it featured elsewhere, but this is my first experience with a real Amiga accelerator. So in this video, I'll take you on a tour of the Dicke Olga. So what is this new fancy accelerator anyway? Well, let's start with its name. The Dicke Olga card, according to the documentation, is actually German, with Dicke meaning fat. Why the strange name? Well, apparently, Dicke Olga is supposed to be a North German woman that you wouldn't want to meet. She's big, powerful, uncompromising and unrepentant. Just like the card. So we've learnt about its name, but what does this card actually do? Well, over the last few years it's been through several revisions, and at the time of purchase this was the latest, and I ordered the advanced model too. And my first impressions when I opened it? Well, I have to say, for a hobby project this card sure looks professional and well made. We'll have a closer look at the card in a minute, but first, the version I have has the following specification. The MC68030 processor with MMU clocked at 50 MHz. A socket for an optional FPU and an optional crystal. A 40-pin and a 44-pin IDE connector, primary and secondary IDE channels. A hole in the back of the card for a compact flash card. Sockets for SATA and M.2. 2 clock ports, one normal and one fast. A switch on the back to disable the card, putting it into so-called 68000 mode. Another switch on the back to disable or enable the auto boot ROM. A socket to support the Defina sound card. Support for the MapROM tool, and uses the LIDE device driver contained in the boot ROM. Now that's a lot of features from a single accelerator card, but then, much like most things with the Amiga these days, this card wasn't cheap, so let's take a closer look at it. Unpacking it from its anti-static bag, and you can really see this card is a beast. Mind you, it's designed to fit the whole length of the Amiga 2000 anyway. Now let's get a little bit more intimate with it. Starting from the front and on the left hand side of the card, these chips, of which there are several, are all octo-bus transceivers. These are just for interfacing the card with the Amiga. There's a few jumpers along the top of the card. Most of these we do not need to touch at all. This connector here is a JTAG connector for reprogramming the lattice chip here, something we shouldn't need to worry about. This is the main CPU, and below it, a socket for the optional floating point unit. In its current configuration, the FPU would use the same clock as the CPU, but you can change it using this jumper here. And once you do that, you have to install your own crystal here. There's also a nice convenient connector here for a fan, for I guess if you decide to overclock the CPU maybe. Moving across the card, these jumpers allow you to change the speed of the card between 30, 40, 50 and 60 MHz. Now 60 MHz is beyond what this CPU should technically be able to do, but some will run this fast quite happily. Then we have another JTAG connector, this one for the Xilinx chip below, and above it we have the boot ROM. Below that, I suspect that's probably our 128 megs of RAM. Now, moving across we have some more interesting bits. This IDE connector is the secondary IDE channel that can support 2 devices. Now you see this chip here, this is very important, it's a SATA bridge chip. It translates between SATA and IDE interfaces, but only for one device, which is why we have some jumpers below so you can change it to be either the IDE master or slave. And the jumpers next to it allow you to swap the primary and secondary IDE channels around too. Also, there's another power connector here, which apparently can be useful if your card doesn't make very good connection to provide the card extra power. And finally, this is where your compact flash card would go. There's also a few more jumpers up there, including enabling and disabling the cable select option, as well as choosing whether the compact flash card should be a master or slave device. This switch toggles the 68000 mode, and this one toggles the auto boot. Now onto the back. There's not much to look at here, but we'll start on the left, and we have an M.2 SATA connector. This one only takes B-keyed cards, and it's important to note that you can only use one of the SATA ports at a time. Now you'll also notice this space overlaps where you could attach a 2.5-inch hard drive to the primary IDE connector, here. And I'm guessing the reason for this overlap is that the SATA and the compact flash connector are all also on the primary channel, and you can't have 3 devices connected at once. Moving along, you'll notice these headers here. These allow you to attach 2 LEDs, one for each IDE channel. Finally, on the right hand side of the card there's two clock ports. Port 1 is a standard clock port, identical to the one on the Amiga 1200. The other clock port is a fast clock port. And that's everything. However, you can theoretically connect up to 4 devices to this, but you have to be careful with compact flash cards, as they don't always play well when sharing the IDE channel, and sometimes they ignore the master and slave settings. So I think the first thing I'm going to do is just install the card and see it working. Now I currently have the Action Replay cartridge installed in the CPU slot, so I'll have to remove that. And I guess I'll have to also think about that dual boot Kickstart ROM switch too. I've already unscrewed the lid, and opening it up we find where we left off last. And I'll start by removing the plate with the Kickstart and Action Replay socket on it, as this is where the card will need to poke out. After this, I'm removing the Action Replay card too. I think for now I'm just going to disconnect the Action Replay cartridge from the Kickstart switch and leave it over on the side. To make installing the card a little bit easier, I'm also going to make a little bit of space by moving the bracket holding the blue SCSI. I'll sort out where that goes later on. Now to install the card, and I can tell you a lot of work has gone into the design here, the angle cut on the front of the card has been designed to help you lever it into the case. And once in, I'm firmly pushing down on the card to make sure it's seated properly. Now that was ridiculously easy to install, so let's power it up and see what happens. And it should just boot my GVP card like before, but maybe just a little bit faster, and I'm going to speed up some of these boot sequences for you too. So no extra RAM, and it doesn't really feel any faster. Let's take a look in sysinfo. After a quick speed test, and it looks like a normal system, and I can see 8 megs of fast RAM coming probably from the GVP card, although that's configured at 4 megs, so I'm not quite sure what's going on there. But it looks like right now this card isn't doing anything. So I'm going to power it off and flip the switches on the back, as I probably have this set in 68000 fallback mode. And now, powering up, nothing's happened. Okay, maybe there's no drives fitted and I need to disable the auto boot option. Well, that seems better, it's booting this time, so it was either that or the card wasn't quite seated properly. And it does feel like it's notably booting a lot faster. Oh wow, and would you look at that? See how much fast RAM there is? That's amazing. Let's take another look in sysinfo. Okay, so it's already detected the 68030, clocked at 51.8 MHz. Not bad at all. We're motor rolling. Well, at 10,158 dry stones, you really can't complain too much. Taking a look at the memory, and first we see 128 megs of fast RAM with the highest priority set, as it should be. Then there's another 4 megabytes of fast RAM from the GVP card. This would be slower to access than the 128 megs of RAM. And then finally, the 2 megabytes of chip RAM on the main board. While I have this open, I'm going to power down and move the blue SCSI card to a different bracket, freeing up the space that it was before. You might be wondering why I'm keeping it in there at all, and that's currently because it's the only way I'm getting internet access on this machine right now. Excellent! So the card works, but we're not really using it to its fullest. So the next thing I'm going to do is install an FPU chip with a suitable 40 MHz crystal. Now the FPU might actually run fine at 50 MHz, but then again it also might be a fake, and admittedly there isn't a huge amount of software that will make use of it anyway, but I might as well populate this card out to the max. Now a nice feature of the design of this card is it allows for both the 8 and 16 pin sizes of crystals too. Now you don't have to use one, but then it will run at the same speed as the CPU. I'm also going to install a blank M.2 card and hopefully it'll be compatible. And then finally, I'll connect a CD-ROM drive up to the secondary IDE connector. I've always wanted to have an Amiga with a CD-ROM drive. And lastly, as it's now a faster machine, I'm also going to put Kickstart 3.2 ROMs back in. that's all installed, and one extra thing I did was to change the jumper for the M.2 device so it appears as a master on the primary channel. And also, did you notice me change the jumper for the FPU clock too? I'm really excited to see this work, so let's power it up and see if I broke something. And I've booted into Workbench from the GVP card again, and the first thing you'll notice is it's asking for a disk with the icon library on it. This is because with Kickstart 3.2 there are a few libraries that are no longer in the ROM, as they simply just couldn't fit them. Lucky for me, I've already prepared a floppy disk with the 3.2 modules ADF image on it, which should just get us past that. Although it appears to be hanging, it's very strange, and... oh, there's Workbench, so I didn't break anything. First things first, I'm going to rerun sysinfo and see if it detects the floating point unit. And there it is! Amazing! I mean, it's still possible it might be a fake and it can't actually run at 40 MHz, but I'm not going to worry about that right now. So let's close sysinfo. So I want to install OS 3.2 on the new card. But before that I need to prepare the M.2 drive and create a partition on it. To use HD Toolbox we need to reconfigure it to use the Lide device instead of, well, I have the GVP SCSI device here. And when we run it, it sees the new SCSI device. However, there's a reason we don't want to use the Workbench 3.1 version of HD Toolbox to prepare the drive. Can you see the problem? It just can't handle drives that big. I mean, it's a 250 gig drive. Kinda ridiculous for the Amiga, but that was genuinely the smallest one I could find. So we'll need to use the Workbench 3.2 version, and to make that easier I've written the install ADF to a floppy disk as well. Like before, we need to configure it for the Lide device. Only this time, when we go into it, it recognises the drive size properly. I'm going to make a small 1 gig partition. A small partition is a good idea for the main system drive because of compatibility with some software, and I'll decide what to do with the rest of that space at a later time. Once saved, I'll reboot. And you'll notice this time it fails to boot. That error is because the partition we've just created hasn't been formatted yet, but the card's attempted to auto boot from it. For now, I'm going to use the early startup menu to tell it to boot from the GVP device instead. And it's taking a while. Oh, I see, it's loading the libs again from the floppy disk. And now booted, I'll format and initialise the drive, and then rename it to Amiga, ready for installation. I'm going to try and tweak this later, but I just want to try, out of curiosity, a quick speed test between the M.2 device and the GVP SCSI card, which currently has the blue SCSI connected to it. Wow, so without even trying to tune it, the drive is 3 times faster already. That is so cool. So we have a drive working, and although I don't technically need to, I'd really like to try and install Workbench 3.2 from the CD directly using the new CD drive. I mean, it's there, I might as well use it. On the install disk there's an option to activate the CD-ROM, so I'm going to have a play with that and see if I can get it to work. Now I can see from sysinfo that the CD drive is detected and it's showing up on device 3. So with that information I'll adjust the settings on the install floppy disk and we'll see if we can get it to mount the drive. Well, that apparently failed. Maybe I need to have the CD in the drive. I'll put the disk in and try again. Oh, so it did work before, it just couldn't find the CD. Oh, well, let's get on with the installation. Maybe I shouldn't have left the 2 floppy disks in the drive, as it's taking a little bit longer reading from them rather than just mounting the ADFs that are on the CD. But at least it's working. And amazingly for me, it's actually installing the rest of it from the CD. I'm so impressed. Oh, and I don't know if you can see it on the camera, but we have a green IDE activity LED flashing on the card too. That is so cool. And after rebooting, we've been prompted to install the extra libraries for the CPU. And once we've done that, I've started sysinfo so you can see that the MMU, or Memory Management Unit, on the CPU is now active. I've never had an Amiga with an MMU before. This is so cool. Now there's 2 or 3 further sets of updates needed before Workbench 3.2 is all up to date, but I'm not going to bore you with those. And also, I'm not planning on using the hard drive on the GVP card anymore, so I'm going to connect the LED on the front of the machine to the IDE interface instead. Makes more sense to me. and it means I can hide the constant flickering caused by the blue scruzzy Ethernet hack I did. There's a header on the back of the card. The header is for 2 LEDs, one for each IDE channel. And yes, it took 4 attempts to get it right. Not only the wrong channel, but as typical with LEDs, you always connect it backwards first. And that's not the only problem here. If you remember back to my original video when I installed the GVP card, I now remember that the hard disk LED on the front of the case was wired backwards anyway. Nice one, Commodore. So last up, I want to have a play with the MapROM program, and I've never played with it before, so I want to see what it can do. And there's one thing I want to try. You can use it to change the wait states when accessing the hard drive for better performance, and the tool apparently defaults to the slowest. So first, I'm going to run the MapROM status command, and as you can see, it's detected the card properly. We can also see that wait states is set to 15, the default. Now MapROM has several different commands that you can run, and I want to take a look at just a few of them. The first is VBR to fast. This copies the VBR or vector base register to the fast RAM. This table is used by the CPU to work out what code to run when an interrupt occurs, so clearly having this in fast RAM is going to be quicker. You can see in sysinfo that it's currently sitting at address 0, so I'm going to run this command, and if we rerun sysinfo we can now see that it's moved. Now I'm not quite sure how to measure the performance improvement there, but it's well worth having anyway. Now there's several other things we can do too, and one is we can use this tool with the command kickrom, which will copy your kickstart into fast RAM so it executes much faster. The other command you can use is called kickfile to copy a different kickstart ROM into memory, so that's an easy way for me to run kickstart 1.3. Now it's important to note that these commands must be ran before the set patch or load module commands, otherwise the computer will refuse to boot until a power cycle. And this lovely dialogue from 1.3 here is a perfectly expected result because it's trying to boot an FFS petition. This leads me to the last thing that I want to test, the wait state setting. Once again, I'll run sysinfo and we can get a benchmark of what the drive's current speed is. Now the documentation suggests that for some compact flash cards, it will even tolerate the wait state being as low as 1. So I'm going to decrease the wait state 1 state at a time and measure the performance difference until it stops working. And don't worry, I'm speeding this up because it's a little bit tedious. And here's the results. I had to stop at wait state of 2 as below that I was getting read errors from the drive. But look at that speed increase! Now that's well worth having. That's around 7 to 8 times faster than the GVP card produced. This card is amazing. Now one thing worth doing at this point is to run something like the file system stress test for a while just to check that it's actually stable at this speed, as we don't want to find out later down the line that it's actually corrupting the disk. And I've massively sped this up, but it ran for ages and ages and ages and I didn't have any problems at all. And as you can see here, I've modified my startup sequence by adding 3 lines. But here's the crazy thing, with those installed, the drive's performance is even higher! Now some people have suggested that sysinfo can max out its speed estimate, so I've decided to give the raw speed controller performance or RSCP a try. First I'll run it against the GVP device, and then I'm going to run it again the Dicke Olga. And then putting those results side by side we can clearly see the speed difference. When comparing this speed to sysinfo, you can see that this program is recording it as a much higher rate. I know some people have achieved faster speeds than this, and there are things that can affect this, from the type of storage used to overclocking the CPU. But as a baseline for me, this is excellent. Well, that just leaves one job of putting the case back together, although this time I'll have to remove the blanking plate on the front to allow the CD drive to poke through. The colour match of that CD drive worked out really well. It's such a great eBay purchase. I'm really pleased with the finished result here, but when I first got the Amiga 2000 there was a part of me that thought it was a bit of a dressed up Amiga 500 because to a certain extent it kind of was. But with this card installed however, it feels like a completely new machine and I'm going to have lots of fun exploring what I can do with it. The Dicke Olga card may be on the pricey side, but anyone with an Amiga will have come to expect this. And with the absolute amazing build quality of this hobbyist card, it's actually very well deserved. It's such a pretty looking card too, look at all those LEDs. It's almost a shame to hide it all away inside the box. Maybe I need a transparent acrylic lid for it. Anyway, I hope you found this interesting. Give us a thumbs up if you did. Thanks for watching, and I'll see you in the next one.